Hi friends, welcome to GMK tutorials. In this video, we will find out the voltage gain and input and output resistance impedances of the given circuit. That is a problem. Okay. So for this case, they mentioned that some given data GM is equal 5 milliseconds, RDS drain to source resistance is equal 15 kilo ohms. So in this case, you will find out the voltage gain, AV, input and the output impedances. So the circuit diagram for this case is equal. This is the circuit diagram. So obviously it is a multi-stage amplifier. Up to this one, it is a one stage. So this is a second stage. So stage 1, stage 2. So that means it is nothing but a multi-stage amplifier. So if you want to find out the multi-stage amplifier analysis, we need to follow some procedure. Obviously we discussed that procedure also in the starting of our videos also, I think. Okay. I don't know whether it may be present in this video or maybe previous videos. I don't know exactly. We need to follow some 4 processes. So that is nothing but identify the corresponding value, identify the corresponding type of the configuration, whether it may be common source or common drain configuration. We need to identify such a kind of analysis is also very important while performing the problem related. Okay. So at the same time, second thing is nothing but draw the medium frequency AC equivalent circuit and find out the related. So that is a general process, right? We need to follow the 4 steps. First one is nothing but identification of the circuits. That is nothing but so it is nothing but a common source. So the first one is nothing but a common source. So the first part is nothing but common source with bypass resistor with resistor. So this part is nothing but a common source. It is also CS without bypass. So that is a difference between the corresponding 2 configurations. So now if you want to find out the corresponding values, first of all you have to draw the medium frequency analysis. Therefore at that time you have to replace the C1, C3 and the C2 are with a short circuited and C4 is also connected with a short circuited. So for that purpose, if you draw the equivalent circuit diagram, this is the overall represent. I think all of you having basic idea. That's all. Draw the completely for gate, source, and drain. So obviously there is some assumption is also there. So the resistance, the input resistance, that is nothing but a gate resistance RG. So this value and this 2 kilo ohm resistors are connected in a. So actually 5.6 is also connected to the ground and the 1 mega ohms and 2 mega ohms and 200 ohms. These two are connected in this fashion. Therefore, this is a circuit, overall circuit reduced. That means the circuit can be designed after performing some modifications. So that modifications I will note down here. So that modification is nothing but simply just after calculating the values, we mentioned that values, right? So that values is generally called as a first assumption, that is nothing but RL2. So RL2 is equal to here RL2 is equal to 2 kilo ohms. RL2 is equal to 2 kilo ohms. Generally, if you want to find out the RL2, that means generally if you want to find out the RL2, what is the basic process? So the first one is nothing but, second one is nothing but AV2, right? So AV2 is nothing but without bypass capacitor. AV2 is nothing but a without bypass capacitor. Therefore, so for that purpose, we need to follow some methodology. RL2, load resistance of the second one. RL2 is equal to load resistance, right? RL2 is equal to, we need to follow the methodology, that is nothing but RL2 is nothing but parallel of those two. So in case of we don't have any load resistance at all, therefore RL dash or maybe RL2 second transistor is equal to, you can directly represent the 2 kilo ohm resistance. So 2 kilo ohm resistance. At the same time, that is nothing but RL2 is nothing but we don't have any load resistance here. Therefore, just this value, that is generally RL dash is equal to, that is nothing but load resist, general formula is nothing but RDS, that is nothing but RD parallel with RL. This is a formula actually. So in this case, we don't have RL value, therefore RD is equal to 2K. So that is the final value for RL dash. So that is the one value. Second thing is nothing but voltage gain formula. So voltage gain formula is nothing but in the output side voltage gain formula. Therefore overall voltage gain AV is equal to voltage gain is equal to. So for that purpose also we have a formula here. Already we derived that formulas. So voltage formula is equal to AV is equal to minus GM into RL dash divided by 1 plus GM into RS. So that is nothing but a source resistance, right? So from that you can calculate the AV is equal to voltage gain. AV is equal to formula minus GM into, so minus GM into voltage gain. Gain means that output voltage. So output voltage is nothing but gain. So this current related to equivalent. If you go for the equivalent model, you will get some idea. So this equivalent current source and the corresponding voltage drop across the load resistors. So that gives the voltage AV is equal to minus GM into RL dash by 1 plus GM into RS value. So this is the formula. So for that purpose minus, so GM is already given in the data, that is nothing but 5 milliseconds. So given is equal 5 milliseconds. At the same time minus GM is equal to minus 5 into RL dash is equal to RL2 dash is equal to here. Just I will call as a RL2 dash. Therefore that is equal to 2 kilo ohms. That is equal to 2 divided by 1 plus GM is equal to 5. So at the same time source resistance. So in this case source resistance is nothing but input resistance. That is nothing but so Ri is equal to Rj. That is nothing but 2 mega ohms. Therefore that is equal to 2 mega ohms. So 2 mega ohms is nothing but obviously 0. Source resistance is equal to, in this case you will get a 0.2 value. So 0.2. So 0.2. Why? So 0.2. Therefore obviously GM is equal to 5 milliseconds. So 5 into 10 power minus 3. So at the same time source resistance 10 power 6. So 3 get cancelled. Therefore 2K, right, around, you can call it a 0.2 around. So let it be take for analysis point of view 0.2 actually. So that is nothing but source. Sorry, that is nothing but input. It is not input resistance. It is nothing but source resistance. It is not input resistance. It is not input resistance. Source resistance is nothing but 0.2. They already mentioned the problem itself only. So that is nothing but 0.2. So from this you will get a source resistance of 0.2. Therefore you will get that value is equal to minus 10 divided by obviously you will get a 2. Therefore that is equal to minus 5. Voltage gain AV is equal to, you will get a value of minus 5. So you will find out the voltage gain. At the same time input resistor, output resistance RL dash is also you will calculate. These two already calculated. So the next one is nothing but, what is the next one? Input resistance. Input resistance is nothing but Ri2. Input resistance at the second transistor Ri2 is equal to, input resistance is equal to Rg resistance of the second transistor. Rg2 is equal to, that is nothing but 1 mega ohm. So that directly from the problem itself we will take that value. At the same time you need to calculate the output resistance RO2. RO2 is nothing but, if you want to find out the RO2 output resistance, you have to use the formula RO2 is not the RO2. RO2 is equal to RDS plus 1 plus mu into RS. So what is the value of RDS? RDS is also given in the problem. that is nothing but 15K plus 1 plus mu value is equal to gm into rds actually. So mu is equal to gm into rds. If you are calculating with the help of those two values, you will get the value of 75, right? You get a 75. Therefore, just you have to substitute 75 and the source resistance of 2, 0.2K, 0.2K. So if you are calculating all the values, you will get the value of around you will get this. You will perform the, you will calculate the simplification. You will get the value just approximately note down here 30.2K, 30.2 kilo ohms. That is for RO2. So output resistance of the second transistor. But we need to calculate RO2 dash, right? So that is nothing but final value. So RO2 dash is equal to RO2 parallel with RY2. So RO2 is nothing but obviously 30.2K, right? 30.2 is parallel with RO2 is nothing but 30 point output resistance is parallel with the drain resistance. RY is nothing but drain resistance of second transistor. So from this, that is equal to 2K only. So it is also K. Therefore, you will get 4. So 60.4 kilo. So you will get, so sorry, there is a parallel value. Suppose if you are calculating 8.7K. So I think it is very clear, guys. Just based on the previous values only, we will calculate these two. RO2. That is the for stage 2. So for stage 1, you need to follow the stage 1. You need to calculate the remaining values. So for stage 1 also, you need to calculate RL dash. RL dash is equal to load resistance. RL1 dash is equal to RL1 parallel with the corresponding RI2. RL dash is equal to RI2 dash. So from that you will calculate that value. RL2 is equal to 5.6K. 6K is parallel with 1 mega ohm. Therefore you will get the 5.6K. That is nothing but RL1 dash. So load resistance of the first stage. At the same time, input resistance RI1 of dash is equal to input resistance is equal to RG1, that is equal to 2 mega ohms. So that is also given data. So based on the corresponding problem. So at the same time, AV1 is equal to output voltage, that is equal to minus GM into output resistance at the so in case of the first stage, it is nothing but a bypass capacitor. So for bypass capacitor, there is a formula variation. So minus GM into RDS parallel with RL1 dash. So you will calculate minus 5. RDS is equal to 15. So drain to resistance 15 kilo ohms and RL dash is equal to 5.6K. So we will calculate all the values. You will get minus 20.38. So that is the voltage gain. So next one you have to calculate the RI dash. Already calculated. Output resistance is equal to, so the overall analysis is equal to overall analysis for this is the final value for this case. Overall analysis, input resistance you need to calculate RI dash, output resistance R0 dash, we need to give the AV value. So these are the final values. So for that purpose, input resistance RI dash is equal to input resistance, that is the input of the corresponding RG1, that is equal to 2 mega ohms. Output resistance R0 dash is equal to RO2 dash. RO2 dash is nothing but obviously RO2 into parallel of that resistance. RO2 is nothing but obviously that can be calculated as around 30.2K. So there is a formula for RO2 is equal to RDS plus 1 plus mu into source resistance. So there is a formula for in case of the transistor CS in without bypass configuration. So there is a formula variation. So just you have to very important criteria. You have to note down that one also. So R naught dash is equal to output resistance, that is equal to RO2 dash output resistance of, so that is equal to 1.87. Okay. At the same time, voltage gain is equal to, it is a product of AV1 into AV2. AV1 into AV2. So first stage is equal to, you will get minus 20 . So just a minute. So AV is equal to voltage gain AV1 into AV2. So AV1 is equal to minus 20 point. Just there is a small technical issue. Just a minute. So I will take the new slide. AV is equal to AV1 into AV2. So that is equal to, if you substitute the AV1 and AV2, so AV1 is equal to minus 20.38 into AV2 is equal to voltage gain of the second transistor. You will get that value is around AV is equal to minus 5. So you will get a resultant value of around, you will get in terms of 101.99. So this is the overall analysis. In case if the problem is given in case of the multi-stage amplifier. Okay, suppose if you want to find out the voltage gain and all those things, first of all you have to identify what is the type of a transistor. That is very important. So based on the type of a transistor, you will get some clarity. So based on that, there is a formula variation. So first stage is nothing but obviously the common source amplifier with bypass capacitor. Second one is without bypass capacitor. So without bypass capacitor, there is small variation of the formula. That is nothing but minus GM is varying in case of the without bypass case. So this is a case for RO2 formula variation. At the same time, gain formula also, so some little bit variation. That is nothing but GM into RL dash into RL dash into RD parallel. But if you go for the without bypass case, there is a formula for voltage gain. So this is very important. You have to note down these formulas. Then you can calculate the voltage gain, input resistance, output resistance. Okay. So those is the important consideration. So thank you guys. Thank you for watching GMK tutorials. So వీలైతే లైక్ చేయండి, సబ్స్క్రైబ్ చేయండి, షేర్ చేయండి. So thank you guys for your support. Really thanks.